we will take another step toward it, and then tomorrow we're going to do very similar questions again. So we're doing these real-life world problems for 3 straight days to make sure that we get super comfortable with them and that we manage to work them out pretty easily, okay? All right, so we have a do it, and the do it is like the part 1 questions that you're going to be getting on your test. It's like quiz questions that you've been having. So hopefully you look at these and you say, man, these are pretty easy. That's what I would hope, all right? Next, write the equation of a line whose slope is 2/3 and whose y-intercept is 0. As soon as it tells me to write the equation of a line, I'm thinking of y equals box, x box. Now, in the first box goes what? Slope. What's the slope in this problem? 2/3. Good. What goes in the last box? The y-intercept. What is the y-intercept here?
0.
0. So you could write plus 0, but normally we don't. So I just write y equals 2/3 x. That's the answer to the first one. Now, by show of hands, how many people got that right? I'm looking around the room, and I'm seeing slightly less than half. That's a question we should be getting, everybody should be getting right. That's an easy question, folks. Next, write the equation of a line. So I see write the equation of a line, I automatically go, y equals box, x box. That is parallel to y equals 5. The same y-intercept as this one. Let's do the y-intercept part first because that one's like pretty normal. Gabriella, what's the y-intercept?
+3.
+3 it is, because it matches the y-intercept on that line, which is 3. And then it says it's parallel to y equals 5. Now, we haven't done any lines that look like this. What's the slope of this line? No.
5 over 1.
No.
0.
0. Why is it 0? Where's the x? Fix your hood. It's right there. There's no x at all. So what this really is y equals 0x plus 5. So if I graphed this line, I would begin at 5, and I would go up 0 over 1, up 0 over 1, up 0 over 1. So it's actually a perfectly horizontal line. And that should make sense because when we talk about slopes, we said that was positive, we said that was negative. Now, what number is in between the positives and the negatives? 0. And that slope is the perfect horizontal slope like that, okay? All right, so we've covered 1 and 2. 2 is kind of like a little bit of a trick situation that we have to see a couple of times. Now, what's the equation of the line that passes through 3, 0, and 4, -2? Here's 3, 0. Here is 4, -2. What's my slope? What's my slope, guys?
2 over 1.
Am I going up or down?
Oh,
Down. So it's -2 over 1 or -2. But let's continue the slope so that I can go back to here and I can find the y-intercept. So there is my y-intercept. 1, 2, 3, 5, 6. So I get y equals, my negative sign didn't come out right there, -2x plus 6. Okay? Y equals -2x plus 6. Any questions about that? Any questions at all? Yes?
Like, I think I know how you, like, I did, like, to find the slope, I did, like, the y to the second, find it.
Oh, you can do that, no problem. It's not y to the second, it's
Okay.
y from the second point minus y from the first. There's 2 and 1, so I would get -2 minus 0, that's a -2, over 4 minus 3, and that gives me -2 over 1.
Yeah.
So I get the same slope, and that's nice, it's very good, but I really want to be able to then trace that slope back to find the y-intercept.
And, like, how do you, like, graph, like, I don't understand how you get the y-intercept.
Well, all you gotta do is connect the dots, that's how you draw a straight line. So I went from here, or I should say from here to here, and I connected the dots. And then I follow the line, y-intercept means where it crosses the y-axis. That's where it crosses, what's that value? 1, 2, 3, 5, 6.
Yeah, but, like, from what point did you, like, graph the slope? Like, I got stuck there, like, the -2 over 1.
It doesn't matter where you do it.
Just,
Like, you could go from here to here, to here, to here, and then just extend that line all the way until it hits the y. What's
pick
that?
a point and then do the
Pick
slope.
2 points
Alright,
and make a straight line out of the 2 points. The slope for this whole line, everywhere you go, any points you use is always down 2 over 1. Or it might be down 4 over 2 or down 20 over 10, but that ratio of down 2 over 1 always stays the same. Okay? Any other questions? Okay, so we talked yesterday about these real life word problems. And here we have Mrs. Wilson's oven. Oh. But I changed the numbers though. Mrs. Wilson oven increases in temperature at a constant rate. You know what? Before we even consider Mrs. Wilson's oven, let's figure out or remind how to set the axes up. All right? Bless you. So let's label the graph, set up the axes, etc. Let's do that now. And in a minute or so, I'll put that part of the answer up on the board. And then we'll have you guys play around with this and try it and see what you come up with. Kyle, you with me on this? Let's get everything labeled and set up, right? Come on, label, set it up, Selena. Time goes across the bottom, right? Temperature goes up the left side. Yeah, go. What? Your notebook? What about your notebook? What?
Usually I write down stuff.
Yeah, you don't need it. If you need it, why didn't you bring it?
Forgot.
Oh, well, you're not gonna leave now and forget it. You're supposed to be learning now. I never let kids go to their lockers to get pens, pencils, notebooks, stuff like that. You gotta remember to bring it. The good news is, everything you need is right in front of you. Okay, so, we said that we have to label and set the thing up, so let's go with oven temperatures as the title. And this side will be temperature. And this will be time.
Can I use this pen?
And you should label it time and temperature. Those words really need to be there. As far as temperature goes, we said yesterday they're gonna go up by tens. So I don't wanna make it too cluttered. 10, 20, 30, 40, 50. Right on the line. 60, 70, 80, 90, 100. 10, 20, 30, 40, 50. 10, 20, 30, 40, 200. 10, 20, 30, 40, 250. 260, 70, 80, 90, 300. Now going across the bottom, I'm just gonna do it by twos. I mean, I'm doing it by ones, but I'm only labeling it by twos. So every box is 1 minute, but I'm labeling the twos. That way it just doesn't get too cluttered, that's all. If you did 1, 2, 3, 4, 5, that's fine. It's just as right as mine is. I'm naturally a sloppy writer, so I wanna try to keep it as neat as possible. What's that?
Doesn't fit. There's
What
so
doesn't
many
fit?
boxes if you do it by ones.
Yeah, we'll work it out. We'll work it out. You can do it by twos if you want, that's fine. Okay, so anyway, after 5 minutes, the temperature is 120 degrees. Now, one of the key understandings that we tried to get across to you guys yesterday is that normally, any point is x comma y. But in this problem, there are no x's and there are no y's. So instead of a point being x comma y, what will any point be? Time and temperature. Okay? So, it says after 5 minutes, the oven temperature is 120 degrees. So I'm gonna go to 5, I'm gonna go to 120. There it is. 5, 120. And after 10 minutes, the temperature is 150 degrees. 10 minutes, 150 degrees. Now, there are my 2 points. That is something every person should easily be able to do. Now, what is the slope in terms of boxes, not in terms of actual temperature? Roach? Well, what is it in terms of boxes? Up how many, over how many?
3, 5.
Up, God bless you. The slope would be up 3 over 5 in terms of boxes. So I'm going to do this way. Ready? 1, 2, 3, 1, 2, 3, 4, 5. And then I'll do another up 3, 1, 2, 3, 4, 5. Right here. And I'm going to go a little bit off there. Right to the edge of the graph. So there is my graph, and it's completely drawn. Okay? Now, what's the first question under the graph on the paper? Because I can't see it.
What will the temperature be after 15 minutes?
At 15 minutes, what will the temperature be? So here's 15. $180 it is. One more time, how did I do that? I used the graph to read the graph. Ready? Look in here, Ethan. I go up at 15 minutes, 14, 15, 16. I go up at 15 until I hit the graph. Then I go over to see what my corresponding temperature is. The temperature is 180 degrees. What's the next question?
What will the temperature be after 20 minutes?
What will the temperature be after 20 minutes? It doesn't fit on the graph, so let me come back to that one. Does the last one say something like a rule or something like that?
No, what is,
What temperature did the oven begin heating? This is
Okay.
C.
Let's go with this. You ready? Oh, all right. What temperature did it begin heating at?
5?
No. No.
90,
90. Who said 90? 90's right. Why?
because that's the y-intercept.
That is the y-intercept. Good. At time 0, temperature's right here. It's 90 degrees. So the oven was 90 when we started to heat it. Now listen. Let's come up with like a y equals mx plus b for this. Now, I know the slope says 3 over 5, but what does every box equal when it goes up?
10.
It equals 10. So it's really 30 over 5. And what does 30 over 5 reduce to? 6. So it's going to be y equals 6x plus, now what did we just say the y-intercept was?
90.
90. All right. So now I think we can answer what the oven temperature is in 20 minutes. I can take the 20 and put it in for x. So the temperature is going to be 6 times 20 plus 90. 6 times 20 is 120 plus 90, 210. That would be my temperature. And if you extended the graph out a little, you would hit 210. And that would be the value at 20 minutes. What's that?
That's what I did. I just extended it.
Yeah, and you could definitely extend it. Watch. It's going to go up 3, 1, 2, 3, over 1, 2, 3, 4, 5. And if you do that, if you go over 5 from 15, you have to end up at 20 minutes. So at 20 minutes, I go over to 210. So I can do that too. And both ways are really good ways to do the question. And you should know how to do it both ways. Okay? Any questions? No, we're good? Okay, so how many people remember doing questions like that yesterday? Good. Now, let's do the other kind that we didn't have quite as much time for yesterday. Louis Landscaping puts the same amount of money in the bank each week. The money is added to some money he started with in the savings account. After 3 weeks, he saved $400. After 5 weeks, he has saved $500. Graph the amount of money Louis saved, or money saved by Louis, below. Go ahead, take it from beginning to end, and then I'll put the answer up on the board. If you want to work together, if you're feeling like you don't know how to do it, feel free to work together. I just want to make sure that conversation is all about math. Spencer, would you do me a favor? Take this and the pass, And just run it to the main office and ask one of the secretaries to get it done. Sure. Thanks. Sink right back there. Gabby, I think if you look underneath where you are, open up the cabinet door, I think you'll see some soap. Maybe even a sponge. Okay, girls, please do me a favor, don't giggle, right? All business.
There's no soap.
No soap. Well, keep working. I'll label it, right? Set everything up. Thank you. Another minute or so, guys. It's looking really good. How much money can you begin to save this with? Yep, it's center line all the way to here. And where intersection times zero, that's $100. It'll go, it'll keep going, connect the dots. Just extend it all the way until there. Guys, I'm seeing a number of people who have dots on their page, but they're not connecting the dots. You should be connecting the dots. Right? You're making a line out of this. You're not just putting points on the graph. There's an old saying, 2 points determine a line. So you have a line there, use it. Anthony, come on, let's go, work. You can't sit there and wait for me to do it, right? It's okay to make mistakes. Try as hard as you can. People make mistakes all the time. It does not make you bad. What makes a kid not learn is not trying. You try, you're gonna be okay. What's that? Okay. You got one more free point, right? Keep working. Under a minute, guys. Okay, let me get my setup and then we'll go over this. Okay, now I want to hold this up for you, and I want you to see something here. Everybody see Roach's work? Everybody see that? Just remember what it looks like, okay? Here's Angela's work. See what that looks like? Do they look alike? No? Here's Issue's work. If you would have just extended that line. All three can be right. Yet all three look very different. That could be right too. I was actually inspired by Ethan's work, so I figured I would kind of use a number scale very similar to the one you were using. See, it all depends on what your scale is. I looked at Ethan's paper, and Ethan went up by 50s, right? Yeah, so I said, let me do the same thing as Ethan. Anybody use a different scale? I know you did. What'd you do, 25s? 10s? You did 50s?
Yeah.
Really?
This goes up to 1,550.
Okay, so we'll put that in. You went up by hundreds. Anybody else use a different scale? Well, I could see people using 25s, I could see 50s, I could see hundreds. I could even see 10s. That might be a little small, but I could even see 10s. So the point is, you can all be right, Gabby, and your graphs can look different. All right, I'll try to remember to finish that one up tomorrow. We'll start with that one tomorrow instead. Hasta la vista, vaya con Dios, toodaloo, ta-ta. Arrivederci, smile a lot. Ciao, arrivederci. Adios, amigos y amigas. What's up, Ishi? Oh, you did that other one already? All right, wise guy.